Okay, for what we have in the Aleks section 3.2 worksheet, and we have for the first item, okay, here we have an exponential function in the form of g of x is equal to 2 raised to the x plus 3 degree, and it says to graph this function and give its domain and range using interval notation. Okay, so for what we have here, again, so we have functional notation with g of x, and g of x is a functional notation for what we otherwise say is going to be y. And I would just sort of clarify. Okay, so I have again, okay, we have y is equal to g of x. Again, g of x is the functional notation counterpart for what we have as y in the xy coordinate system. And for what we have here, we can take what we have and go ahead and identify the domain and the range. And now for what we have in the case of the domain is going to make reference to what we have in x. And now in this particular case, you can plug in anything for x in x plus 3, to which we will raise the exponential base 2. Okay, and so for x, we can plug in any real value. Okay, if you have like 2 to a negative power, 2 to the 0 power, or 2 to a positive power, you're going to have something defined in the output. So we have for the domain, we can plug in anything for x. So the domain is going to be the set of all real numbers. And now there's a little bit of an advance, okay, because section 3.2 does not go into logarithmic functions yet. But if you have 2 raised to a negative power or to the 0 power or to a positive power, the output is always going to be positive. Okay, so whatever we have for x that we pick out from the real numbers, 2 to whether x is negative or 0 or positive, 2 to that power is going to come out to us anything from a very, very, very small positive value or to a positive value that is very large, but it will still be positive. So for the range, what we have for y, or in this case for g of x, the output is always going to be positive. So that means that we'll be looking at the range as being the set of values y greater than 0, and we have an interval notation. We have the range, again, will be the set of values y that will be greater than 0. And now, and just looking at graphing, if you have, say, for the sample of inputs for x, say from -6 to -3, -2, 0, and 1, your corresponding y value, okay, we have 2 to the x plus 3. So if I have x at -6, we have 2 to the -6 plus 3, which will be to the -1/3 degree. We made that to the -3 degree. And 2 to the -3 is going to be the reciprocal of 2 to the 3rd. And 2 to the 3rd is going to be 8. And the reciprocal is going to be at 1/8. And this will come out to 0.125. So for the ordered pair, then we have -6, 1/8. You can also write this as where the fraction is going to be a decimal, so you have 0.125. And if I have x at -3, now y is going to be equal to 2 to the -3 plus 3. So we're going to have 2 to the 0, and 2 to the 0 is equal to 1. So for the ordered pair here, we're going to have -3, 1. And say if I go with x at -2, okay, so y is going to be equal to 2 to the -2 plus 3, which would be 2 to the 1st. And 2 to the 1st is equal to 2. So we have another ordered pair where we have at -2, 2. And if I go with, let's say, x equal to 0, we have 2 to the 3rd. And that's going to be equal to 8. And you have another point on the graph of this exponential function we're going to have at 0, 8. And if I take out to x equal to 1, we'll have y equal to 2 to the 1 plus 3, or in this case 2 to the 4th, which will be at 16. and the order pair is going to be at 116. And just taking what we have with these points, and this is what the graph is going to look like. And 116, this will be sort of out of the boundary of what we have in the worksheet's graph, but you're able to plot like -618, -31, -22, and 0.8. And again, the range, you have the minimum to be the smallest possible positive value that exists, and you have the range going all the way up to infinity. And for what I have in x, you're going balancing between negative and positive infinity. Now for what we have in the second item, okay, you have the dollar value v of t of a certain car model that is 2 years old is given by the following exponential function, where we had that v of t is equal to 20,000 times 0.95 raised to the t degree. And it says to find the initial value of the car as well as the value after 10 years. And it says to round your answer to the nearest dollar as necessary. Okay, so we're looking for the initial value as well as the value of the car after 10 years. Okay, so looking at what we have in the setup and we have in the equation. Okay, now we have for the initial value, so we have at t is equal to 0. So we have for the value, we have v of t is equal to 20,000, and we have times 0.95 to the 0 degree. And okay, so we have in this case you have the initial value, have v naught, and 0.95 to the 0. Okay, non-zero number to the 0 power is going to be equal to 1. So you have 20,000 times 1. So the value at the start is going to be equal to $20,000. Okay, so we have in this case, all right, so you have the initial value of the vehicle is going to be at $20,000. Now, if we're looking for the value of the vehicle after 10 years, okay, so we have at t is equal to 10. So after 10 years, okay, we're going to have for v of t, and where t is equal to 10, okay, so I'll just go ahead and write this as v of 10, and we have is equal to 20,000 times 0.95 raised to the 10th power. And now for 0.95 to the 10th, now you're going to perform exponential operations before you do multiplication. So I'm going to keep 20,000 at bay, and I'm going to take exclusively 0.95 raised to the 10th power, and we have among the first digits, so we have 0.59873, and you're going to keep these particular numbers, okay, and we have so you have like 11,974.74 something, and so to the nearest dollar, okay, you're looking at right at $11,975. Okay, so for the value after 10 years, okay, this be right at $11,975. For what we have in the case of question number 3, we have a species of fish was added to a lake. The population size P of t of this species can be modeled by the following function, where t is the number of years from the time the species was added to the lake. So we have our function P of t is equal to 2800 all over 1 plus 9 times e raised to the minus 0.3 times t degree. And it says to find the initial population size of the species and the population size after 7 years. And it says to round the answers to the nearest whole number as necessary. Okay, So we have utilizing the very same function. And so taking what we have for number 3, so we have our function, and we have for the initial population. Okay, this is whenever the time span is at 0. So the initial population, and this is where t is equal to 0. And so we have p of 0 is equal to 2800. We have all over 1 plus 9 times e, and you have minus 0.3 times 0. And I'm just going to sort of drag this on out. Okay, so you have 2800, and we have all over 1 plus 9 times e to the 0. And now e is going to be our natural logarithm exponential base number, and a non-zero number to the 0 power. Okay, now e is the number that's right at 2.718, and a non-zero number to the 0 power is equal to 1. So for what we have in this case, we'll have 2800 all over 1 plus 9 times 1. So we have, with the initial population, we have 2800. 1 plus 9 is going to be 10. And 2800 divided by 10, this will come out to 280. So the initial population will be at 280. And looking at what we're going to end up with after 7 years. Okay, so utilizing the same function, and so we have at t is equal to 7. So we have the population after 7 years is going to be equal to 2800. And we have all over 1 plus 9 times e to the negative 0.3 times 7. And we have this equal to 2800. And we have all over 1 plus 9. Now e to the minus 2.1, or e to the minus 2.1, what we're going to have here is going to be a number that's a little bit over 12 hundredths. Okay, so we have 2800 all over 1 plus 9, and e to the minus 2.1, have right at 1.1224. And if you multiply 9 by that number and add 1 to it, so we're going to have what's going to be 2800 over about 2.102. And for what we have after 7 years, you have about 1,332. Okay, so for the population after 7 years, okay, we have about 1332.